Welcome. Last time we talked about finding area between the x-axis and the graph of a function. We can generalize this a little bit. We can use the same ideas to find the area between graphs of two functions. I have two functions, f of x and g of x, with the graph of f of x above the graph of g of x, at least in the interval of interest. And I take the region bounded by these two graphs and lying over that interval. So I have some interval from a to b, and I have the function f on top, function g on the bottom. I'm going to do the same thing we did before. Divide this region into thin vertical strips. A typical strip will look something like this. We'll assume that f and g are continuous. Then if the strip is thin enough, continuous functions cannot vary too much in very thin intervals. So I can think of this region as being approximately a rectangle. The area of the rectangle will be the height times the width. The width is dx. What about the height? If I take a point in that interval, approximate the strip by a rectangle where the top is given by the value of f at that number, bottom by the value of g at that number. We take points on the graph corresponding to the number we picked, namely x, take the rectangle to have the same height as the strip at that point. So I have to find the distance from the point x comma g of x to the point x comma f of x. If f of x is above g of x, it will simply be the difference between the two y coordinates, and that's f of x minus g of x. So the area of the strip will be f of x minus g of x times dx, and total this in the limit, that will be just the integral of that difference, f minus g from a to b. I like to think of this as saying that the area when we use vertical strip is the integral from the leftmost x value to the rightmost x value of the top boundaries equation minus bottom boundaries equation, if they are given in the form y equals some function of x for both. Of course, as with regions bounded by the x-axis in the graph of a function, it is permissible for one or both of the two vertical sides to shrink down to a single point. Now let's find the area of the region bounded by the graphs of 8 minus x squared and 2x that also lies in the first quadrant. So it's the region shown in the picture here. The top is this parabola. From the graph you can see that it lies above this straight line. X goes from 0 to whatever the x coordinate of this point is. So I need to find that point. That's where these two intersect. In other words, that's where 8 minus x squared equals 2x. I have to solve that equation. It's a quadratic, so I'm going to put it in standard form, which gives me x squared plus 2x minus 8 equals 0. I can solve this by factoring. The left-hand side factors as x minus 2 times x plus 4. So they intersect when x is 2 and also when x is negative 4. We are interested only in the first quadrant portion, so it must be where x equals 2. We don't really need to find the y coordinate of the point. We are not going to use it in our calculation. So I have to integrate the top minus the bottom. So 8 minus x squared minus 2x from the leftmost value of x, which is 0, to the rightmost value, which is 2. So I have to integrate from 0 to 2 the function 8 minus x squared minus 2x. Again, I'm just integrating a polynomial, so after this point it's very straightforward. Find an antiderivative, which I can do by using the power rule, and then take the net change, in this case from 0 to 2. So substitute 2 for x, and then substitute 0 for x, and then subtract. And finally, I just have to do this arithmetical calculation, which gives me 28 over 3. Let's do one more example, this time the area between graphs of two functions, namely 7 plus 2x minus x squared and x squared plus 4x minus 5. If you draw the graphs, they are both parabolas. We get a picture like this. The two parabolas intersect at 2 points, and the only region whose boundaries consist of only these two parabolas is the region in between them, this portion. Again, we'll just use our formula, which is that the area equals area of the top minus area of the bottom, with x going from the leftmost x coordinate to the rightmost x coordinate in that region. They have given us the equations of the top and the bottom, but I have to find the coordinates of the points at the two corners, two endpoints. That is where they intersect, so that's where the two functions are equal. Set the two given functions equal to each other and solve for x. Again, it's a quadratic equation, so I'm going to simplify and either factor or use the quadratic formula. If I bring all the terms over to the right, I get 0 equals 2x squared plus 2x minus 12. I can pull out a 2. X squared plus x minus 6 factors as x plus 3 times x minus 2. So the two graphs intersect at points with x coordinates negative 3 and 2. Again, we don't need to worry about the y coordinates, so I'll just ignore them. The area is the integral of the top, 7 plus 2x minus x squared, minus the bottom curve, which is x squared plus 4x minus 5, with x running from x coordinate of the leftmost point, that's negative 3, to the x coordinate of the rightmost point, which is 2. Again, I just have a polynomial, so from this point on, the calculation is easy. Simplify, distribute the minus and combine like terms, which gives me 12 minus 2x squared. Then integrate term by term using the power rule, and then take the net change. So substitute the upper bound, that's 2, the lower, that's negative 3, and then subtract, and that's the area. I will leave the arithmetical calculation to you. Couple of things to note. One easy mistake to make, especially if you don't draw the graph, is judging which is on top, which is on bottom. If your answer comes out to be negative, that's the first thing you should check, especially if the integration is easy. The other possibility is that you are going from right to left rather than left to right. You always want top number to be bigger than the bottom number when you set up area integrals. One way to check that you're subtracting in the correct order is to just pick some number in between these two, for example 0 in this problem, and verify that the function you are integrating is positive for that x value. If x is 0, this function is 12, which is positive, and that tells me that I am in fact subtracting in the correct order. Other thing you have to be careful about is that the two graphs intersect only at 2 points. If they intersect at more than 2 points, or more generally if the graphs cross each other, so one is above the other part of the time and they get switched the remaining part of the time, then this simple formula doesn't work. We have to do something else, and we'll talk about it next time.